So this is the 4.5 practice, although this could be done with just on your own. We're going to try to do some of these together. This is full screen. Okay. So this is the same 4.5 practice you have where it says at the top, what is the best method to prove triangles congruent? And although you could think through this yourself, since I'm not here today, I'm going to go ahead and try them out together with you. We could do full proofs on these, or we can just kind of set up a possible proof. Just so we get in practice, I think it would be good to try these out as proofs, the ones that you can do. It says, use the information given to decide whether or not the triangles can be proven congruent. Now, if they can, then we would try to decide which postulate or theorem, and then we don't actually have to do the entire proof, but again, just for practice, let's go ahead and try it, because I think the hardest parts are going to be writing out your statements properly so that everything's matching. But the good news is we are going to skip the first one, actually, because deals with circle, radius, and we haven't learned circles yet. And so rather than bring up something that's not quite on your yellow sheet for right now about like the radius of a circle being the same and things, we're going to skip that one. So don't worry about number one. Moving on to number two, it says, given that angle K is congruent to angle E, and again, the first thing you should start doing is start marking your diagram. Then we have OA is congruent to YB, and finally KA is congruent to EB. And that's all that's given to us. We don't have any other givens. So if we're just working with what's here, right now this shows two sides and an angle. Two sides and an angle means I can either have SAS or SSA, which is not possible. Remember, on this yellow sheet, the only one that deals with two sides and an angle is SAS. And so if I wanted to do SAS, if it's possible, that's great. But remember that SAS requires the angle to be touching both of the sides. This angle is not touching both of these sides, neither is this angle here, right? So since that's not going to work here, we're going to go ahead and write SSA is not possible. I'm going to just cross it off and write not possible. You don't have to say the reason why, we just know it is not possible here. All right, so that's it for number two. We do not need to do anything else because it's just not possible to prove those. But number three is a good one. It shows us lots of triangles in this diagram. But the ones we're being asked to prove, it helps to outline those specific ones, whether you're using two different colors, highlighters, pens, whatever it is. So the first triangle I'm being asked to prove is STW. So I'm going to outline S to T to W and complete that triangle. The second triangle I'm being asked about is VWT. And as I draw both those triangles out, you want to look for overlaps as you do that, like see how this side was overlapped, because that's going to be part of the proof in just a minute. But let's see what else we have. Let's mark up the diagram for everything. So we have S is congruent to V. Here's S, here's V. And then we have a couple of perpendicular segments, which means I don't know this yet, but I'm going to eventually get that the two angles are going to be right angles, because we know if perpendicular, then right angles. But specifically, where are they? It's saying ST with TW. That means I'm going to get a right angle right here, but I don't know it yet. I'm going to have to show that in my proof by saying if perpendicular, then right angle. And same thing on this side, if perpendicular, then right angle. Okay, so that'll help me kind of get, so far I have two angles that I will either already have or I'm going to get very soon. I just need a third piece now, whether it's, and it has to be a side. Remember, there's no such thing as AAA. There's no three angles, so it won't help to get the final angles here. I don't want those. I want to get a side. I specifically could get a side that's included between these two angles, so that could be like ST with VW, or I want a side, the other two sides, which doesn't matter which side you get, it's just going to determine whether it's AAS versus ASA. And so if I look at my givens, it doesn't tell me anything about the sides, so I can't use anything from my givens knowing that is ST congruent to VW? I don't know that. I don't know anything about these diagonals or the hypotenuses, right? Both of those, I don't know anything about it. They didn't tell me anything. But what I do know is this segment here, the overlapping segment. I know that TW and WT, both of those are going to be referring to the same thing, but for two different triangles. And this is something we haven't seen very often, but we talked about this property in Unit 3 when we were talking about what is reflexive property. We learned about it, but we never really used it in proofs often. Well, here's where it's coming up. So I'm going to have my 2-column proof here, and I know it's a little tight on space. So we have our given, and again, you didn't have to do a 2-column proof here, so if you don't want to write this specifically down, you could kind of just write down some thoughts of how you would approach this proof. But right now we're just writing out the givens from the top there. Okay, so those are all 3 parts of the given. We have S is congruent to V angles, and then we have ST is perpendicular to TW and VW is perpendicular to TW. That's how we got those right angles. So I'm going to start with those right angles. I'm going to go ahead and say if perpendicular, then right angles. And remember, the then part has to match what I write in the statement. So I would say angle, and I want to be clear here, not just call it angle T, because there's an overlapping angle here. So I do have to name it STW, or I could have said WTS, but has to be congruent to then VWT. Look at the order of the letters as I name that angle. I did STW referring to this angle in the same order I have to do VWT. So far I already knew an angle, and I just got, right now I haven't, actually I'm sorry, I jumped ahead. I have not said that they're congruent because remember, I only know that they're right angles right now. So I don't have the A yet. Then step 3 comes, and I could say if right angles, then angles congruent. And that gets me my second angle. Okay, and I can write them out as congruents now. STW is congruent to angle VWT. Okay, and now we just have a few final steps here. We want to show that angle, we want to show that we have our third side that we marked on our diagram right here. I want to show that that's congruent. The reason for that, in the reasons here for this 2-column proof, is reflexive prop congruence. Now that's going to come up a lot this unit. Anytime you see an overlapping side where something is congruent to itself, you're going to get reflexive property, and it's going to be this final side that I have. And then we know that we just did angle, angle, side as we kind of work through this. So this would be AAS, but let's write in our missing statements. So for step 4, for the reflexive property, we want to say what side is congruent to itself, and you get to pick how to write the first side. You can decide which triangle do I want to do it for. So let's say I want to do TW. Then technically, looking at this first triangle, TW is the second and the third letter. And so if I come over to this other triangle, then I have to pick the second and the third letter, which are W and T. The order there switches because W is corresponding with T in the other triangle, whereas T is corresponding to W in the other. So it's kind of confusing here to remember how to switch it. Not always is that going to happen, where both the reflexives will be different like that. We just have to kind of look out for when that happens. We'll see on the next one what happens. And so then our final step is writing out the 2 triangles that are congruent. Okay, so we have STW with VWT. All right, and we just proved these 2 triangles congruent. Here's another one at the bottom. We have YW is bisecting XZ. So it's a segment that's being bisected. I don't know yet that they're congruent, but I'm going to have to show it. Right now, all I do know, though, in my given is that XY is congruent to ZY. So I have so far one side, and I'm going to get these 2 sides also eventually, right? So this is something, I'll circle it just because I don't know it yet. Even on this last proof, I could have circled this part saying, I don't know it yet, but I'm going to get that part once I show it. Okay, so far I have 2 sides. Well, remember, there's only SAS or SSS that deals with 2 or more sides. And so I can't do, and there's no such thing as SSA. So if I wanted SAS, I would have to know something about angle X up here with angle Z down here, but unfortunately there's no information given to me about those being congruent. So I don't know that piece. Instead, I do know one more piece again, which is the reflexive. Because this side is common to both triangles, it's exactly the same side length, which again, I'll have to show that in my proof. So here's where I'm going to start writing it out. Again, you don't have to do a 2-column proof if you don't want to. I know it didn't specify here. I just think it's good practice. And we may not do them all, but just to get an idea of how to work through these. So number 1 given, write out all of our givens. YW bisects segment XZ, and segment XY is congruent to ZY. Okay, step 2, you can start with either the reflexive property, or you can say the if bisects, segment bisected then, and if you need help finding where that is, it is at the top here. If segment bisected, then the segment divides into 2 congruent segments. Okay, so I'll just start there because that was my first given. Segment bisected, then divide into 2 congruent segments. And I want to write down what those 2 segments are. So on the left here, and so far I have a side that was given to me in the given. I'm about to get another side here with XW, right? And if it goes X to W, I have to then do Z to W for the second one, just so that the order of the letters matches. You can look at your congruent statement to help you see that X and W are the first and the third letter, and Z and W are also the first and the third letter for the other one. Okay, and now we're ready to keep going, and here's where you would say reflexive again. It does come up often. Doesn't mean it has to be on every proof, but that's how we get this third side, and it is the common side. Now this time, if you're noticing, W is the same W for both triangles. You can kind of see it here. YW and YW did not change the order of the letters from the second to the third, so this, you could say YW is congruent to YW. Don't forget the segment bars. Or you could have said WY is congruent to WY. It really doesn't matter which one you write. I'm going to write it here, but you really shouldn't write both on the proof. Pick one. Okay, so, but I don't want to switch around the letters like I did on this last one, because this one, that's how they corresponded. The order of the letters did change on the 2 triangle congruences for the second and the third letter, but here they don't. And so that's why we want to make sure you're keeping it the same. And that's enough to go to SSS congruent and write out the 2 triangles. All right, and ZYW. So we're going to do one more proof together, and it's going to kind of lead us to this brand new theorem that we're about to see, that it's on your yellow sheet that we didn't get to yesterday. And then for the rest of the 2 examples that are left, you can get a chance to try them out, and we'll go over them tomorrow as well. So if you can turn to the back page here, we're going to see this new theorem here in a second, which is called RHL, and it's literally what it stands for. The R stands for, we're going to write it out, but it tells us in 2 right triangles, if the hypotenuse or both hypotenuses are congruent and a pair of legs is congruent, then triangles are congruent. And you would be able to use RHL just like we've been using SAS, ASA, SSS, and all these other ones. But the key things you have to look for is I need a right triangle, and I need a pair of hypotenuses to be congruent, and I need a pair of legs. Now, it doesn't matter which legs you have congruent, because we know we have 2 legs in a right triangle. You get to pick which ones, but literally the R stands for right triangle, the H stands for hypotenuse, and L stands for leg, just to make it easy for yourself. And we're going to kind of walk through this in this first proof. I'm going to change this a little bit, though, because if we had done this one, you wouldn't have seen this RHL working right away, and I want to show you how it works. So let's say change this triangle, the given, instead of it saying it was bisecting that angle, let's say instead that angle XWY and angle ZWY are right angles. Okay, so let's say the given told us that right from the beginning, like it's as if this was a typo, so Just ignore that it was, don't worry about crossing it off and so on. It would be given to you like this, and now we want to work with it. So if we know that XWY and ZWY are both right angles, we're going to see some right angles that are then going to be congruent. We also already know that XY is congruent to ZY, so we have a side also. And then the third side is my hypotenuse. I'm sorry, not my hypotenuse, my reflexive side, which is actually a leg. Now I circled it because I don't know this yet. I'm going to have to show it in my proof. This is reflexive again because the sides are common. So almost every proof today shows reflexive. It's going to probably be like that a little bit on the homework as well. But just keep in mind that's not every single proof always. It's one of those easy steps to see. Okay, so looking at this diagram here, I have a side, and an angle. And remember, there's no such thing as SSA. So when you get to that predicament of, oh no, SSA doesn't work, I can't use that, what else am I going to do to prove these triangles congruent? This is where RHL can come in, because I have right triangles. And specifically, the R does stand for right triangle, not right angle. So you have to be clear there. I do know that the hypotenuses are congruent because I just saw the XY and the ZY were given to me. And I have one set of legs congruent as well. That's the I have the reflexive side here, WY is congruent to itself. So I'm ready to do this proof. Starting with my given, I'll write out XY is congruent to ZY, and I have angle XWY and angle ZWY are right angles. Because remember, I changed that part of the given. So far though, you have a side, but instead of just writing an S for a side, specifically the side I have are hypotenuses. So I'm going to change my S to actually be an H, because in RHL, once you realize you're using RHL because you're working with right triangles, you know that you have that H. Now that doesn't mean that every single time you have right angles, you're always going to use RHL. It's just this is what we're seeing so far. Okay, so we're going to go ahead and start with our second step here now. I want to show if right angles, then here's the part that you want to be careful with. I know that we usually say if right angles and angles are congruent. But I'm not trying to show that two angles are congruent to each other because I don't need an A for like SAS or AAS or ASA. Instead, I need to show that this is a right triangle. Well, there's a reason. It's all the way on the front here, and we kind of often didn't use it. It is right below the part where we kind of already outlined Unit 1, but we stopped with all these triangle ones. This is the one, and you can kind of star it on your own if you'd like to, or just know that this is the one that we use with RHL. It says if triangle with right angle, then right triangle. Now, even if you didn't say it exactly like this, if you said if right angle, then right triangle, honestly, that's fine. But we want to make sure we're using this one that says then right triangle, not angles congruent. So actually, I'm going to rewrite this completely. If triangle with right angle, and we're really only working with one right angle because each triangle has its own, then right triangle. Okay, so if triangle with right angle, then right triangle, that means this side, which I'm about to get an R for, I need to just say what my right triangles are. And I can use the same order of letters as what's up here. So I can say XYW and ZYW are right triangles. Just kind of stating a fact that I have some right triangles here. And now I'm ready to finish up with the reflexive again. Reflexive prop congruence gives me that third side, which is a leg, RHL. The leg here is WY, and it's WY and WY, or YW and YW if you want to go in the order of the letters here, whichever way makes sense to you. Just know that it has to not switch on this one because the W corresponds to W, the Y corresponds to Y in both triangles. It doesn't ever switch like that first example. And now you're ready for RHL, congruence, and the last step will write out the two triangles being congruent to one another. So triangle XYW and ZYW. Okay, so that's kind of the thought process on a lot of these is you are trying to decide, first of all, from your givens, what should I do? Have a plan before you start jumping right in and deciding. So what I'm going to do for number 6 is just plan it out with you, and then you can try it out, and then same for number 7, and I can give you an idea of how many steps as well. Sometimes it's shorter than others. These have been basically 4 to 5 steps, I believe we just did, but the next one is a little bit longer. It's going to end up being about 6 steps unless you work through it a different way. And then the last one, though, is only 4 steps, so that one's a little bit quicker. Okay, but let's just outline it. I'm not going to do the full proof, but you can definitely try out the 2 proofs, and then I'll go over them tomorrow. But the idea here is we have some parallel lines. I like this one because it does bring in some parallel lines. So I'm going to draw in the arrows, whoops, for TV and SW. Okay, so we know they're parallel to each other. You can draw them out like this, or just the arrows. Okay, and now we have some perpendicular lines as well. So ST is perpendicular to TW, which means I'm going to get a right angle there. But again, I don't know it yet. I'm going to have to show all of this eventually in my proof. I'm going to have to say if perpendicular, then right angle. Same thing with the second one, VW with WT gets us a right angle right there. So it looks like we have a right angle, so we have to decide, is it going to be RHL or is it one of the other ASA, or AAS, or SAS? We'll have to see once we get the rest of this. So because I had some parallel lines, I probably do want to try to get some alternate interior angles if I can, or corresponding or something else. The most common ones are usually alternate interior. And if you're wondering which transversal should I use, if I try this top transversal, there's nothing above it on the other side. So that would be more of like a corresponding angles, but let's see, if corresponding can't quite work because I have this other transversal that's creating this angle. So that doesn't work. Same thing down here, this transversal doesn't get me, because it's like more than one transversal is creating some of these angles, so that doesn't help me. So instead, the transversal I want to use would be TW, and I have this parallel line, this parallel line, and the transversal shows me on opposite sides of that transversal, but in between the 2 parallel lines, those are my alternate interior angles, which I'll do in a different color here so that you can see. I'm going to have to show those are congruent. So I'm going to have my right angles, I have my other alternate interior angles, and I have another reflexive property congruence. So this one is set up for ASA. And so I'll write that here. ASA means you will not use right triangles. You're not going to use the one we just did up here that said if triangle with right angle, then right triangle. Instead, you're going to have to do 2 steps to get to this point. You're going to say if perpendicular, then right angle, and if right angle, then angles congruent. That's going to get you 2 steps just to get these 2 congruent to each other. You're going to get a reflexive property as well, and if lines parallel, then alternate interior angles congruent. All of that will help you get to 6 steps finally to get to ASA. Okay, so if you'd like to try that one out, that would be good to write out, because I think sometimes what happens is missing steps is very easy to do when you don't say like if perpendicular then right angle and you try to go right to right angles are congruent. That would be a problem. Same thing with the parallel lines, making sure you can say you have alternate interior angles and write the angles, everything properly. So when you try this out, make sure you're finding the order of the letters properly. This one didn't fill this in. It wants you to try out filling that in, matching the different angles. Like notice V goes with S. So that's how you know what letter comes first. But then think about T. For this triangle, T is a right angle. But then over here on this triangle, W is the right angle. So it's switching the order of the letters. Okay, so it would be SWT instead. Okay, and then same idea for number 7 down at the bottom. This one's a little bit quicker. It's only 4 steps. So once you get your given congruence, you're going to show angle bisected on this one. BAC gets split into 2 congruent angles, and then also another reflexive property to finish up with SAS on this one. Okay, so if you have questions on these, bring them tomorrow, but hopefully you're getting the gist of these, and you can always try out more examples other than homework. You could try these homework ones, and then of course there's also the review that you've already gotten early for later this week. Okay, but if you have questions, just bring those with you